Welcome to the annual December of Kits. Today, assisted by Grandpa's Sweater Oatmeal Stout from Barnhammer Brewing in Winnipeg. This has been a favorite for a very long time, a nice roasty malty stout, just what you want on a cold winter's night. So let's dive into the big box of kits and see what we can pull out for today. As you can tell, it's overflowing, including the one that Jeff sent me in the last mailbag. But I think I'm going to start with something a little bit less complex. What do we got in here? This ultrasonic suspension standing wave controller kit. So let's see what's all involved in this guy. It came in a mailbag a couple of months back, and I remember being a little bit confused by it until I remembered that I'd ordered it. But what it appears to do is use these two ultrasonic modules to create an acoustic standing wave. And in the zone of influence, I guess, of that standing wave, it will allow these little foam balls of various sizes to hover, suspend, float in midair. Or at least that's what it promises. So we've got a circuit board, we've got some standoff hardware, got one chip and these two ultrasonic modules, and then a small smattering of components, including a couple of surface mount components. There's a second PCB. Okay. If I remember correctly, one of them hovers up here with one of the ultrasonic modules, and these standoffs hold it up there, and the other ultrasonic module is down here with a couple of chips, and is that probably a regulator over there, I'm guessing, and a 12-volt input. And there is the schematic and parts list and everything else. Let's zoom in on that schematic. So we have a power LED, power in there. We have a regulator, 1117-5 volt. Okay. Smoothing capacitors on either side of it. And that is your 5-volt power supply. There's 5 volts going out. And the 5 volts comes into the two chips. There is one ultrasonic module. Where's the other one? Oh, maybe it comes off there. Sure, probably. I don't know what these two chips are. I mean, I can read what they are, but, This one is an STC, a microcontroller. Okay, STC 8G1K17A. So that presumably is generating a signal that goes to this thing, a TC4427. Let's go find out what it is. It is a 1.5 amp dual high-speed MOSFET driver. So it is intended to be driving higher power MOSFETs, but on its own it's capable of handling up to a 1.5 amp load. Okay, 4.5 to 18 volts, sure. And even though it is intended to be driving MOSFETs, it has a pair of MOSFETs in sort of a push-pull configuration at its own output. So that will be what's driving the two ultrasonic modules. I suppose it could have used actual MOSFETs on there, but that's a little bit tidier solution. So we have an order of operations here. Let us see what they want to do. Step one is to put in that chip right now. Normally, I would not want to start with semiconductors when I'm putting together a kit. Normally, I would start with resistors and ceramic capacitors and mechanical bits and pieces. However, I am going to follow their instructions. Why not? Let's see where it gets us. So we'll set up this little circuit board in my board holder. I don't know that I've used this for a round board before, but it seems to be working fairly well. Okay, let's go with that. And I might as well dump all the components out to get to our itty-bitty little surface mount device. So on the board, there's the dot that indicates pin 1 down in this corner, but I don't see a dot on the chip. I'm going to guess that pin 1 is bottom left when the text is the correct way up. Hopefully that's right. I guess we'll find out pretty quickly here. So typically with surface mount stuff, I will tin one pad in one corner of the chip, just a little bit. And then bring the chip in and remelt that, get it roughly in position, kind of tweak it around a little bit so that all the pads are lined up, and then pick another corner and burn that one down. Let's retouch that first one. There we go. And then just get the rest of them soldered in place. Now this tip is probably way too big for doing this, but I'm going to make myself suffer anyway. And yeah, we've got bridging and stuff there. I'll fix that up later. Put a bit of flux onto some desoldering braid and just quickly touch those ones that have got way too much on them, and hopefully that should pull the excess solder out. What I probably should have done earlier on is to put a smaller tip on this iron, just so that I could do these surface mount things better. But I guess better late than never. There, that's a lot easier with the fine tip. It was possible, of course, with the coarser one, but whatever, we got there. So, next step is the 1117 regulator. Okay, I'm going to just rotate the board around a little bit to get that where I can get at it easier. Just like before, a little bit of solder on there. I probably should be using tweezers or something like that for positioning this thing, but as long as I don't burn my fingers, I should be good. Or maybe I will use the tweezers. There, that's actually less awkward than I thought. Get another pad down here. And the big one, which I don't know if I'm going to be able to get to work well here because there's so much copper there. Oh, that's way too much solder. Perfect. All right, what's next? 1K resistor and a couple of capacitors. That would be that 1K resistor there, and I guess those 200 nanofarad capacitors. I'm not sure why they gave me 2 resistors, but at least they were civilized enough to mark them, so that's nice of them. That resistor goes up here. Yes, I could have used a tool to bend those. I do have one, I just choose not to. It's just as easy to do it by hand. Then the 2 little capacitors, they are both the same, so this one here and this one up here, these are both part of the power supply circuit just for stabilization. I was a little concerned this tiny tip would not have enough heat transfer for these through-hole components, but I needn't have worried about that. It works just fine. Next step is the LED. It has a positive marked on the left-hand side, and positive is the long lead on the LED. And with larger LEDs, you can usually see the flat spot on the little skirt of it. You can kind of see it on this little 3mm guy too. Or you can just give it a quick test and verify for sure if you happen to have a tester. So that's down there. I do like that they are only putting a couple of components in at a time and then getting you to solder them. The benefit of... Ooh, I've got to clean my iron here. The benefit of that is that the legs don't get in your way. Because I have gotten all rambunctious in the past and put, every resistor in and found that I couldn't get at it because, my soldering iron was just getting interfered with all the component leads. So next in is the 8-pin IC socket. And nice touch, they even tell you to make sure that the notch is aligned with the screen print. Another nice touch, they actually package the dip components in a bit of foam, which protects the legs from getting all mangulated. So there's the notch that they were talking about there, which indicates the pin 1 end. And there's a notch there. And for the socket, it doesn't really matter, except for it's going to mess you up later and confuse you when you go to plug the IC in. But it's always a good practice to do. I'm just going to stick that down with a bit of blue tack just so it stays in place while I flip the board over to solder it. And I know it doesn't matter on things like a socket, but I always like to spread my heat around while I'm soldering, get one corner, and then go as far away as possible. Is that settled in there? Not quite. So I'll give that a press. Remelt those two. I'll get some pressure on. There. Now it's down flat to the board, and I can quickly solder down these guys. The two 10 microfarad capacitors. They are both electrolytic capacitors, of course. Pay attention to the positive and negative electrodes. As we can see, there is a negative indication on the electrolytic capacitors, also the short leg. These ones are 10 microfarad 50 volts, and since our circuit is only running on 12 volts, that should not be a problem. On the board, we have a positive indication there on that side. Get in. And a positive indication there. Okay. So that goes in nice and easy. Quick solder job on those. This board is taking solder very nicely. Some of the cheap kits that you get, you have to use extra flux or do a cleaning of the board even beforehand, but this one looks like the pads are all pre-tinned and they're taking solder very nicely. Right, so what is next? The 12 volt DC input. Again, pay attention to the hole positions. So the hole positions, I mean, there's only really one way to put it in, so I don't know why they said to pay attention to the hole positions, but here we are. And again, just so that it doesn't drop out when we flip it over, let's do that. This is going to have some very big pads, so it may take more heat. You have to linger a bit longer. Oh, that's not too bad. This is going very quickly and easily. The next thing to do is the two ultrasonic sensors. Pay attention to the positive and negative. The one with the black circle is the positive. So that's these two guys. One goes on each board. As they mentioned, the one with the black circle is the positive. So that goes in that orientation. Blu-Tack to the rescue once again. Again, these are really heavy pins, so I'm going to have to linger a little bit longer than I'm usually comfortable with. That worked very nicely. Let's get that board out and do the same thing on this one. I'm going to assume that this guy goes on the silkscreen side rather than that side. Positive there, goes there. There's my blob of Blu-Tack. So next, put the chip in, and then the mechanical stuff. So for putting the chip in, we have to make sure it's pointing the right direction. And again, there's a notch on that end. And because it was shipped packed in foam, those pins are not bent, which is awesome. Set it in the socket and make sure none of the pins are bent out of the way, and then give it just a little squeeze. Double check. Yep, I think we're good. So now, mechanical bits. We have 4 tall standoffs and 6 smaller ones and some screws and stuff. Okay, let's see what this has to say. So it looks like 4 nuts and 4 of the short spacers, M2x5 plus 3, 5.3 maybe, copper posts. Okay, so that is 1, 2, 3, 4. So that is our feet, I would guess. That is tiny and fiddly. But yeah, that gives us 4 feet, the thing to stand on. All right, I'll just quickly do that. There, it's got a nice sturdy footing. And then Okay, so the standoffs stack up there to get the other board up high. So there's a stack of 3 standoffs for each one. We have 1 nut left and a bunch of screws. I'm assuming since these are all M2, they were expecting you to lose a few of them along the way. And so far, I don't think I have. But yes, these are fiddly little things. Again, for my big fingers, these M2 screws are just way too small. So just looking back at this again, it shows building it without those 2 extra little ones. Strong suspension, high practicality, or you can add them for more beautiful look, but the suspension effect is poor. Recommended to use Scheme 1, this one, which is what we've got it built for, so we'll just go with that. So that is the -1. You can tell by the negative there, and that is the -1 on that side. So that goes like that, and there it is. So we got those bits left over. Now then, I guess we just plug 12 volts into it. Alright, I got 12 volts set on my power supply. Let's see what happens. On, we have LED. It's drawing about 20 milliamps. That's good. That's always my first concern with a kit, is that it doesn't draw too much current, which would mean that I've shorted something. So let's get you a better camera angle and see what happens if we put some of these little foam balls in there. Okay, let's try this. Oh, come on, let go. Let go of my tweezers. Fly and be free. There's so much static on these things that they won't let go. That's annoying. Okay. I just don't want to get off my tweezers. Come on, you guys, play nice. That doesn't look like it's doing what it's supposed to, does it? No, it's just sitting there. So let's just see if this is doing anything at all. And these 2 pillars are the electrical conductors between the top board and the bottom board. Okay, yeah, we got a 19 point something or other kilohertz square wave there, so there is some kind of a signal getting to the little ultrasonic transducers, but they obviously aren't interested in levitating these little foam balls. So we know we've got a signal going up to the top board and up to that top transducer. And according to the schematic, the 2 ultrasonic transducers are sitting in parallel electrically. So unless I screwed up soldering massively, that shouldn't be an issue. This guy is obviously putting out a signal, otherwise we wouldn't have been able to see it on the scope, which means that this guy's alive too. We've got the power supply LED, so we've got a pretty good idea that all this is working. Well, since I don't have any easy way of detecting whether that transducer is actually putting out a signal, I think what I'm going to do is hook my scope up to one of them and see if it can receive a signal from the other one. So if I do that, there is a signal both being transmitted from the bottom one and being received by the top one. When I turn off the power supply, it kills it. When I turn it back on, it's there. So that tells me that both transducers are functioning. So just double checking some things and making sure that the negative connection is in fact connected to the shell of the thing. So I didn't get either of them backwards. Double checking my assembly. I may have made a mistake, but I don't think so. Usually I try and be fairly careful when I'm doing these things, on the off chance that somebody might actually be following this video in the future as instructions. But sometimes I do get carried away when I'm talking to you guys and make mistakes, but I'm fairly confident that this one is done correctly because it was a fairly simple kit. So that's the positive there, and that's the positive there. Right, so let's power this guy back on again and see if we can make any of these little balls levitate. Power on, nothing happens, none of those little guys bounce. No, it's just not doing it, and I do not know why. So this is the part in the video where I ask, have any of you guys built this kit before and got it to work? We'll leave it in the comments below. Well, that's disappointing, and I don't want to leave you guys disappointed and hanging, so let's just grab a tiny little kit out of the bin and put that together, and hopefully I can get that to work. I don't understand that one. I don't understand why it's not doing it, other than maybe it's not a great kit. Let's see what this little guy is, and hopefully that will redeem us. It's a little bug-shaped circuit board. It calls itself the Weevil Eye, and it doesn't come with any instructions, but it does show component placements on the back. So we have 3 resistors, 2 LEDs, a transistor, and what goes back here, ground, oh, power, okay, and VCC up there. And for power, it's got a little battery holder. You're gonna have to figure out what size battery that is. We have 3 resistors, a transistor, the LEDs, and a photoresistor, which I didn't see on here. So is that photoresistor what goes across the back of the bug here? Does that look like it would fit? Yeah, and it sort of matches the silk screen there. Okay, we'll go with that. Should I go and look for the listing where I bought this thing just so I got a picture of it? That would be the wise thing to do, especially given the bad luck I've had so far. This isn't the exact place that I bought it from, but this is the same kit. So it looks like all the components go on this side. And what does it do when you put your finger over the photo sensor, or the photoresistor? Then looks like it lights up the LEDs. Cool. So there's no schematics I could find online, but I spent, all of 2 minutes, and this is what it is. So the positive voltage from the battery goes to the anode of the 2 LEDs. The cathode then goes through their own 220 ohm resistors and to the collector of the NPN transistor. The emitter goes through the negative voltage, and then there's this voltage divider here between this 47K resistor to the positive side and the photoresistor to the negative side, and then that goes to the base of the transistor. So this resistor, whether it's bright or dark, will tell you whether or not, or will control the LEDs to go on and off. It's just that simple, and I should be able to put this together without screwing it up, and I should be able to troubleshoot it if I do screw it up. Sounds good? Let's go. So having no instructions, I'm just going to go with my gut order. And first of all, I guess I better figure out which of these resistors is which. Those two look the same and that one looks different, so I'm going to guess that that's the 47K. Should I check it? Probably. Am I going to? Nope. And these two being the same should be the 220 ohm resistors. I'm really trusting this kit manufacturer to have included the right parts, but, well, I guess we'll troubleshoot if it doesn't. At least it'll be more satisfying troubleshooting than that guy back there, because that thing, again, I have no way of telling what's happening in the little acoustic field that it's supposed to be generating. So at least with this, we'll get some closure on this video. I hope, right? Sure. You know what? This one is soldering just as easily as that other one did. That's one thing that these cheap kits these days seem to have going for them. Most of them anyway. I'm sure we're going to run into some horrible ones at some point. But so far, they're soldering up nicely. Right, let's put in the photoresistor next. And it just goes back here as we saw earlier. Come on, get in. Can't even get this right. Come on, get in there. All right, next, probably the transistor. No apparent reason. I could do the LEDs first, but I just happened to grab this guy first. It is a common enough transistor that I'm not concerned about blowing it up, and even if I do, I'm sure I've got something similar in stock to replace it. Next, the two LEDs. As mentioned before, the long lead indicates positive, the flat side on the case indicates negative, and this board has the flat side shown on the screen print, so I'll put the flat side down like that, and on this one, same direction. Okay. And then last but not least, the battery holder. That's one side of the power, and there is to other. So with the battery in, if I shade that, look at that. It actually lights up. Woohoo! Just like the schematic said, just like we predicted. Cool. That's a win. That's not a win back there. That's a disappointment. So, in the comments, what did I do wrong? I think it is functioning electrically. I just think it's not doing what it's supposed to do for reasons that I don't understand. If you have built this kit and got it working, let me know what I did wrong. And if you have some troubleshooting ideas, also let me know, and I will try them out. And if any of it succeeds, I'll put a quick little video together and link it from this one. But if nobody has any better luck with it than me, well, at least we had a success with this little bug here, which is all we can really hope for, I guess. Well, thanks for watching. Hope you got something out of that. Don't be too frustrated if your stuff doesn't work first try. That happens to a lot of us. You never know. Hopefully some helpful person will be able to guide me in the right direction. And yeah, that's about all I got to say for today. Thanks for watching. I'll talk to you later, and I will be back for the rest of December with more kit builds, hopefully more successful than that one, hopefully more difficult, yet still successful than this one. Yeah, talk to you later.